Hey everyone, and welcome. Today, we're diving into the world of numbers. But, not just any numbers. We're going way beyond the basics to explore a set of numbers that helps us describe everything from some seriously chilly weather to the deepest parts of the ocean. And it all starts with a simple but kind of strange question.
It sounds a little weird, right? I mean, for a long time, people just figured that zero was the bottom, the absolute end. But if you stop and think about it, what happens when things go well below zero?
Exactly.
Like when it gets really cold, the thermometer doesn't just stop at zero and give up. Nope, it keeps on going down. How would you even talk about that biting cold of a winter day in Srinagar without a number like -5? You just can't. Or hey, picture this. You're on a quiz show. You're on a roll, but then, bam, you hit a tricky question, get it wrong, and you lose points. Your score doesn't just go down, it gets a -10 slapped onto it. That's a negative change. Or think about it like this. Sea level. That's our 0 point, our baseline. A plane can be flying high above it at a positive altitude. But a submarine? It's way down below, exploring what you could call the negative zone at -1,200 meters. So to make sense of all these real-world things, we clearly need a bigger, better collection of numbers. So it's time to officially meet the hero of our story, the integers. And what are integers? Well, they're actually beautifully simple. Just take all the whole numbers you already know, 0, 1, 2, 3, and on, and then add their opposites, their negative reflections. -1, -2, -3, forever. That's the whole gang.
The best way to picture this whole thing is with a number line. You've got 0 sitting right there in the middle, holding the center. To the right, all the positive numbers march off towards infinity. And to the left, all the negative numbers do the exact same thing. It's this perfectly balanced two-way street. Okay, so theory time is over. We have our new set of numbers. Let's put them to work and see exactly how they help us solve those real-life problems we were just talking about. Let's start with Mohan's bank account. He puts money in. That's a positive move, right? So plus 2,000. But then he takes some money out. That's a withdrawal, a negative move. So -1,642. The big question is, what's left in his account? Well, we just add the integers. A positive 2,000 plus a negative 1,642 leaves him with 358 rupees. And it's actually no surprise that the first ideas about negative numbers came from tracking debts and credits, just like this. Integers just make it all perfectly clear. All right, check out this table. It's a snapshot of temperatures across a few different places on the same day. And just look at that range. We've got a pleasant 22 degrees in Bangalore, all the way down to a seriously freezing -8 in Lahore Spiti. Okay, so here's a little challenge for you. How much warmer is Bangalore than Lahore Spiti, really? To figure out the total difference, we've got to do a little integer math. Now, the calculation looks like this. 22 minus a -8. And this is a key moment, subtracting a negative number. It's a bit of a classic trick. What do you think is going to happen here? The total difference is a whopping 30 degrees. Think about it. You have to go all the way from -8 just to get to 0, and then another 22 degrees up from there. This just shows how powerful integers are for calculating a total range. Okay, back to our friend Jack and his quiz game. For every right answer, he's getting positive points, but for every wrong one, he's getting hit with negative marks. You can see his score is bouncing up and down. So let's add them all up and see where he lands. All right, let's tally it up. First, all the positives. 25 plus 15 plus 10, that gives us 50. Now for the negatives. -5 and -10, that's -15. So 50 plus a -15 gives us a grand total of 35. Nicely done, Jack. So as you've probably noticed, working with integers isn't just random guesswork. There's a clear logic to it all. They actually follow a few really simple, predictable rules. The rules of the game, if you will, that make them super easy to work with once you know them. So here are the core rules for adding. It's simple. If the signs are the same, like 2 positives or 2 negatives, you just add the numbers and keep that sign. Easy peasy. But if the signs are different, you find the difference between the two numbers. And here's the key, you take the sign of the bigger number. That's it. Now this is a biggie. A super common mistake is thinking that 2 negatives make a positive when you're adding. They don't. Think of it like this.
If you owe me 3 rupees, you're at -3. If you borrow another 2 rupees, you now owe me 5. You've just gotten deeper into the negative.
So we've seen what integers are, we've played around with them a bit, but let's zoom out. What's the big picture? Why is it actually so important to get a handle on these things? Well, it's because integers are so much more than just numbers on a line. They're a code, a language that lets us talk about ideas like opposite, or below, or debt. They add this whole new dimension to our math, letting us describe the world with way more precision. They are the bedrock for so much stuff like algebra, physics, and even computer science. Once you get integers, you can finally fully grasp profits and losses in business, elevations in geography, all those temperature swings in science, and of course, scores in games. Seriously, the applications are absolutely everywhere. So, I'll leave you with this thought. You now have the code. You have this new way of seeing the world in both positives and negatives. So keep your eyes peeled today when you're looking at the news, on your phone, playing a game, and see where you can spot integers in action. I promise you're going to be surprised how often they pop up.